Hi guys, welcome to lesson 10-3, picking up on page 177 in your book. Today we're going to learn the elimination method. You're going to love this. So we want to be able to use the elimination method to solve a system of linear equations and write a system of linear equations to model a situation. So we've been solving these systems using substitution and using graphing, and so you're going to learn how to do it using elimination. Here we go. Elimination is another algebraic method that may be used to solve a system of equations. Two equations can be combined to yield a third equation that is also true. The elimination method creates like terms that add to zero. So let's make sure we know some vocabulary here. The elimination method, also called a linear combination, you might hear it that way next year, is a method for solving a system of two linear equations, and it involves eliminating one variable. So getting one of them to go away. That's why we're going to make them add to zero. This is usually everyone's favorite method once they learn it. To eliminate one variable, multiply each equation in the system by an appropriate number so that the terms for one of the variables will combine to zero when the equations are added. Then substitute the value of the known variable to find the value of the unknown variable. The ordered pair is the solution to the system. It'll make both equations true. So the last part is the same as substitution. From here on, once we find a variable, we're going to plug it back into one of the equations to find the second variable. So the only new thing is the elimination itself. So let's look at this example. Solve the system using the elimination method. So here's my two original equations. To solve this system of equations by elimination, decide to eliminate the y variable. You can decide to eliminate x or y. The reason they probably chose y is because you'll notice in these originals that we already have one that's negative and one that's positive. So if they were the same number, let's say 20, if I could turn them both into 20, then they'd automatically make a 0 because one's positive and one's negative. So in order to do that, we're going to multiply the first equation by 4. So this whole equation here is going to get multiplied by 4, both sides. And then we're going to multiply the second equation by 5. So this whole equation here is going to get multiplied by 5. So when we do that, distribute the 4 to that side and then to this side. Distribute the 5 to this side and to this side. So we end up with these two equations. So now what you'll notice is that if I line these up vertically and add them up, these two guys are going to cancel out. 16 plus 15x gives me 31x, and then 120 plus 35 gives me 155. Then I can divide by 31 and I get x equals 5. Now all I've got to do is plug that back in like we did with substitution. So here's where we found x equals 5. So we're going to go back. It looks like they chose the first equation here, this one. Excuse me. So they're going to plug the x we found into this equation. So instead of x, we're putting in 5. So then we'd have 20 minus 5y and so on. Solve it, and we get y equals 2. So it looks like the solution is x is 5, y is negative 2. I hope I said negative 2. So then we're going to check it in the second equation to make sure it's true. So here's the second equation. Plugging in 5 for x, negative 2 for y. I would get 15 minus 8 is 7, and that's true. So the solution is 5, negative 2. It has to make both equations true, but presumably since we used the first equation to find it, it's going to make that one true. But you could check them both. So you should definitely pause this and try to do it by yourself. In both of these cases, I'm going to go ahead and eliminate the y variable just because one's positive and one's negative. So I'm going to go for making those match up. You could choose x, but you'd have to multiply one equation by a negative number, which would be fine, and you'll get the same answer as me. So if you're feeling adventurous, do that. But either way, pause this, and let's see if we end up with the same thing at the end. Okay, I'm going for the y's. So let's see, I want to make 2 and 5 be the same number. So I'm going to multiply this top equation by 5 and this bottom equation by 2. That'll turn both of my y's into 10 and negative 10. So I would get 15x minus 10y equals, let's see, that's going to be negative 105. And then on the bottom I would get 4x plus 10y equals 10. So when I eliminate the y's, I'm going to get 19x equals negative 95. And then when I divide by 19, I'm going to get x equals negative 5. Then I've got to plug it back into one of the equations. I'll just use the first one to make sure, to find out what y is. So I know x is negative 5. So if I use the first one, I would have 3 times negative 5 minus 2y equals negative 21. So I would have negative 15 minus 2y equals negative 21. When I add 15 to both sides, I'm going to get negative 2y equals negative 6. And then when I divide, I'm going to get y equals 3. So my solution is negative 5, 3. And if I plugged that x and that y into both of those equations, those original ones, they will both come out true. Now for the second one, I'm going to make 5 and 3 be 15. So I'm going to multiply this one by 3 and this one by 5. So I would get 21x plus 15y equals 27. And I would get 20x minus 15y equals 55. Now, one thing to watch out for, in order for these to cancel, they have to be one positive, one negative. Sometimes I see kids cancel out a 15 and a 15. Well, that would make 30. It wouldn't cancel. So make sure you have one positive, one negative. So you'd have 41x here equals 82. And so x is going to equal 2. So I know x is 2. Now I'm going to plug it back in and find out what y would be. So I'm using the first equation. You could use either one. 7 times 2 plus 5y equals 9. So 14 plus 5y equals 9. So 5y equals negative 5. So y equals negative 1. So 2, negative 1 is the point that would make both of these equations true. So here we've got an application problem we get to try. Fong has $2 in nickels and dimes in his bank. The number of dimes is 5 more than twice the number of nickels. So I'm going to have to add 5 more to twice the nickels. How many of each type of coin are in his bank? So let's let D stand for dimes and N stand for nickels. So let's see. He has, so let's say 0.10 is what a dime's worth, plus 0.05, not 0.5, be careful, for a nickel equals $2. So we know that much. And then we also know that the number of dimes equals 5 more than twice the number of nickels. So 2 nickels plus 5 is what the other equation is. So, boy, this one would be a nice one to do substitution on, but I'm going to assume they want us to do elimination. So first, we need the equations to line up. So I'm going to minus 2n to both sides here so I can stack up my equations. So I'm going to have minus, so I'll have, actually, I'll have d minus 2n equals 5 so that my d's and my n's line up. Now, let's get rid of the decimal here. I'd have to multiply by 100 to make this be 5n and to make this be 10, and this would be 200, so that I wouldn't have decimals. So if that's going to come out being 5, if I multiply by 100, and this one is negative 2, I want to turn them both into 10 so that they'll cancel. So I'm going to multiply this one by, this might be a little confusing, by 1,000. Nope, I need to multiply it by 2. So I'm going to multiply it by 200, sorry. Because if I multiply it by 100, I'll get 5. And I want to get 10. So I'm going to multiply it by 200. and then I'm going to multiply this bottom one by 5. You don't have to do this all in one fell swoop, but just watch what happens. So I would have, if I do that, I would have 20d plus 10n equals 400. And then down here I'm going to have 5d minus 10n equals 25. So you can see that the n's are going to cancel. Now, if you hadn't done it all in one fell swoop, you could have gotten rid of the decimals first and then figured out how to make the n's match. It's just a matter of how strong you are at your multiplication and your math facts. So if these cancel out, I'd have 25d equals 425. So if I divide that, I'm going to get my number of dimes. So my dimes equals 17. So now, I know I've got 17 dimes. Now I can plug that in here. 17, I'm going to use this equation just because it's easy. 17 equals 2n plus 5. So if I minus 5, I'll get 12 equals 2n. So n must equal 6. So 6 nickels. Now make sure that adds up to $2. And do I have, let's make sure this is true. Are my dimes 2 times my nickels plus 5? Well, 2 times 6 would be 12 plus 5 is 17. So that works out. And these would add up to $2. You can check it. So let's look at another example here. Most likely the trickiest part when you're given a scenario is to come up with the equations. The elimination part probably won't be as hard. So in this one, Noah is given 2 beakers of saline solution in chemistry class. One contains a 3% saline solution and the other an 8% saline solution. So one is stronger than the other. How much of each type of solution will Noah need to mix to create 150 milliliters of a 5% solution? So he's going to mix together the 8% and the 3% and make a 5% solution. So first we're going to define our variables. We want to know how much of each type of solution he's going to need. So we're going to let x be the number of milliliters of 3% and y is going to be the number of milliliters of 8%. So x is one kind, y is the other kind. So we have to write one equation based on the amounts of liquids being mixed and another one on the amount of saline in the solution. So we know that the amount of this plus the amount of this needs to equal 150. That's how much we're making. So that's just the how much equation, the amount. And the other one has all the percentages. There's 3% saline in that kind, 8% saline in that kind, and there's 5% saline in that final mixture. So those are our 2 equations. Then we're going to solve it by elimination, and it looks like they're deciding to eliminate the x variable. So we're going to multiply the first equation by -3. That'll give me -3x. And then we're going to multiply the second equation by 100. That'll get rid of 2 decimal places, and I'll have plain old 3x. So once I do that, distribute that -3 in, I would get these terms. And when I distribute this 100 in, I would get these terms up here. And then my x terms will eliminate because I have -3x and 3x. My y terms will be 5y, and then -450 and 750 will give me 300. So you always combine these by adding, or basically it's combining using the signs that are given there. Then when you divide by 5, you get y equals 60. So we just found out, it's so important to define these at the beginning, we just found out how much we need of this kind, because we defined out what y is. So now we're going to find the value of the eliminated variable x by using one of the original equations. So if we use the first equation, x plus y equals 150, and we plug in y, we know y is 60, so we're going to plug it in right here. So x plus 60 equals 150. We just replace that right there. And so x must equal 90. So what we found out is that we need 90 milliliters of the 3% solution, because that was x, and 60 milliliters of the 8% solution, because that was y. And if you plug it in, to either of the original equations, you're going to get a true statement. So let's see here. We're going to try solving this by elimination. It looks like the easiest thing for me to do would be to focus on the y values, and I could just multiply this bottom equation by 5, and then they'd automatically cancel out. So if I'm just going to bring stuff over here. I'm going to bring the top one over without changing it at all. I don't always have to change it. Or I can multiply it by 1 if you think you have to multiply it by something. And then on the bottom, I would get 20x minus 5y equals, let's see, that's going to be negative 80. So then my y's are going to cancel, and I'll get 27x equals negative 81. So that means that x equals negative 3. So if I get negative 3 for my x, I've got the first part of my answer. Make sure I keep my x and y coordinates straight. Then I got to go back to one of the originals. I guess I'll just use the first one, and I'll plug in negative 3 for x, and then figure out what y must be. So negative 21 plus 5y equals negative 1. So 5y, if I add 21 to both sides, equals 20. And so y equals 4. So negative 3, 4. If I plug it into both equations, it'll make it true. Let's prove it. So 7 times negative 3 plus 5 times 4 should equal negative 1. So negative 21 plus 20 equals negative 1. Oops, negative 1. And that's my check mark. I was prematurely checking things. So that one's right. If I check the other one, 4 times negative 3 minus y, which is 4, should equal negative 16. So negative 12 minus 4 equals negative 16. Yep, they're both true. That means I got the answer right. All right, so here's a chance for us to make our own equations. To find interest, remember we've got to go principal times rate times time. So that might come in handy. So Mary had $25,000 to invest. She invested part of it at 3% annual interest and part of it at 5% annual interest for 1 year. The amount of interest she earned for both investments was $1,100. How much was invested at each rate? So let's let x equal amount invested at 3% and y equals the amount invested at 5%. Now, you should pause this and see if you can come up with the equations by yourself. That's the trickiest part. So hopefully you figured out that x, the amount at 3% plus the amount at 5% has to equal 25,000. That's how much she had. And then the interest principal, which would be our x, times rate, which would be 0.03, times time, which would be 1. So 0.03 times 1 times x, that would be the interest for that first amount. And then for y, principal is y, that's the amount. Rate is 5%, and time is 1 for 1 year. So 0.05 y, that's the interest she earned on that amount. And the total she earned in interest was $1,100. So let's see, we could choose to eliminate either variable. I think I'll go for I'll go to eliminate my x's. So I'll multiply the top by negative 3, so that'll turn into negative 3x, and I'll do my bottom times 100, so that'll turn into 3x. So my new equations will be negative 3x minus 3y equals negative 75,000, and then that's if I distributed to everything in that equation. And then down here I'm going to get 3x plus 5y equals 110,000. So my x's will eliminate. I'm going to end up with 2y equals, and that's going to be 35,000. And so when I divide 35,000 by 2, I'm going to get 17,500. Let me just pick a, well, I guess I'll just stick with green. So I've got y equals 17,500. So I know she's got 17,500 invested at, and that's why this is so important at the beginning, define what it is, at 5% interest, annual interest. Then I've got to go find the other amount. So the easiest way is x plus y equals 25,000. So x plus 17,500 equals 25,000. So if I subtract 17,500 from both sides, then I'm going to get x equals 7,500. So $7,500 at 3% annual interest. And you can plug them in, and if you add those, if you do principal times rate times time, you're going to get the 1,100 total that she had earned. All right, so we've got another chance to set up our own equations here. So Sylvia's creating a mix, and she's going to make 100 pounds of it, and it's going to sell for $25 a pound. So that's what she's making. And she's using two types of coffee to create the mixture. She's using Kona that sells for $51 a pound, and she's using Colombian coffee that sells for $11 a pound. So we've got to come up with our two equations, but first we need to define our variables. So let's x equal the amount of Kona, and y can equal the amount of Colombian. Those are the two things we want to find out how much we need. So you should pause this, see if you can come up with this by yourself. So hopefully you came up with the amount of Kona plus the amount of Colombian needed to equal 100 pounds, because that's how much she wants to make. Then we got to put the details in here. So the Kona sells for $51 a pound. The Kona sells for $11 per pound of that, and my whole mixture, my 100 pounds of mixture, is going to sell for $25 a pound. So I think I'm going to go for eliminating my x's, and so I need to multiply by negative 51 to the first equation. So I would have negative 51x minus 51y equals negative 5100. And then I have my 51x plus 11y equals 2500. So that's gonna, my x's will eliminate. I will get negative 40y equals, and this is gonna give me negative 2600. And then I'm gonna divide by negative 40. And then I'm going to get y equals 65. So we need 65 pounds of, which one did I just find? Colombian. And then I'm going to plug that in. We know we're making 100 pounds total, so x plus 65, because that's the variable I found, needs to equal 100. So the x, when I minus 65 from both sides, x is going to equal 35. So 35 pounds of Kona. Really important to keep your variables straight so you know which one's which. So there's a lot to that. Hopefully the elimination method makes sense to you. Getting equations set up from real life situations takes some logical thinking. You can do it. Bring your questions and let's pick it up together in class.